everyone, among the mechanical products around us, such as automobile bodies, pressure vessels in factories, and even precision aerospace components. Have you noticed their edges? Are these edges particularly smooth and neat, without burrs or notches? If the edges have burrs, flash, or if the welding groove processing is inaccurate, what will happen? Correct, it will not only affect the welding quality, but may also lead to a decline in the overall performance of the product, and even create potential safety hazards. Today we will explain Project 2. Part Preparation Technology. Task 2.5 Blanking and Edge Processing. CNC Edge Processing. I am the lecturer, Xiaowan Yan. The learning objectives of this lesson are: Knowledge objective: to master the characteristics and applications of CNC edge processing. Ability objective: to be able to perform CNC edge processing of welded structural parts. Quality objective: to cultivate a sense of standardization. Knowledge point of this lesson: CNC edge processing. Key point of this lesson: the characteristics, applications, and operations of CNC edge processing. Difficult point of this lesson: the operation of CNC edge processing. First, let us understand what CNC edge processing is. CNC edge processing is an automated machining process in which CNC equipment, such as milling machines, laser cutting machines, plasma cutting machines, etc., is used to perform precise cutting, grinding, or chamfering of workpiece edges. Its application scenarios include: 1. Removal of burrs and flash. 2. Machining of welding grooves, such as V grooves and K grooves. 3. Edge chamfering, such as C chamfers and R chamfers. 4. High precision contour finishing, such as molds and aerospace components. The characteristics of CNC edge processing are: 1. A high degree of automation, with very high production efficiency. 2. Strong adaptability to different machining objects. 3. High machining accuracy and stable quality. 4. Easy to establish communication with computers, facilitating group control. Common CNC edge processing equipment is shown in the diagram. Next, let us study the selection of CNC edge processing methods and the determination of machining schemes. 1. Principles for selecting machining methods. They must simultaneously ensure the requirements for machining accuracy and surface roughness. In addition, requirements for productivity and economy, as well as the actual conditions of existing production equipment, should also be considered. 2. Principles for determining machining schemes. The machining of surfaces with higher accuracy requirements on parts is often achieved step by step through rough machining, semi-finishing, and finishing. For these surfaces, the final machining scheme should be determined according to quality requirements, machine tool conditions, and the condition of the blank. Next, we will study the selection of cutting tools and the determination of cutting parameters. 1. Selection of cutting tools. The principle for selecting tool materials in CNC machining is to use cemented carbide whenever possible. For precision machining, tools with better performance and higher wear resistance, such as ceramic tools, cubic boron nitride tools, and diamond tools, may also be selected, and tool parameters should be optimized. 2. Determination of cutting parameters. The principle of reasonably selecting cutting parameters is: during rough machining, the main goal is generally to improve productivity, but machining cost should also be considered. During semi-finishing and finishing, machining quality must be ensured while also taking into account cutting efficiency, economy, and machining cost. Today we have systematically studied CNC edge processing. Definition: automated precise machining of workpiece edges using CNC equipment. Applications: burr removal, welding groove machining, edge chamfering, high precision contour finishing. Characteristics: high automation, strong adaptability, high accuracy, easy group control. Operational core: selection of machining methods, determination of machining schemes, selection of cutting tools, determination of cutting parameters. I hope that through today's study, you will not only remember the knowledge, but also regulate operations in practice. For example, strictly following the scheme to process step by step, and correctly selecting cutting tools and cutting parameters. Only in this way can high-quality parts be produced. That is the end of today's lesson. See you in the next class.